Good evening, everybody. We are going to give it a few more minutes here. We're going to let people join up and see all who is with us tonight to finish up the match game that we will be coding. I will show you guys how to get to that if you have not, if you did not start with us last week and have not gone back and done last week's lesson. That's okay. I have all the code that we've done so far that'll be ready to share, and you guys can start from there, and we'll keep going. So let's give it a few more minutes and we'll see who all joins us today. All right, just a few more minutes and then we'll get going. I do want to talk to you guys about our Tuesday situation. Tuesday, we tried a Zoom meeting. It did not go exactly as I had wanted. I think part of the problem is knowing who has access. When I put it out on Twitter, I think there was I know one individual in particular was in the wrong area altogether, and we're also trying to learn about how to set up Zoom to make it work properly in group situations. That's something that one of my volunteers is helping with now. There's just a lot of little bells and whistles to getting a Zoom meeting set up properly, or a Zoom room set up properly. So we're still trying to work that out. What we are going to do, I'll talk about here in a minute, and show you some of the stuff that we've been working on at Future of Code to try to get everything functioning a little bit nicer. Okay, so let's get started. Like I said, I'm going to talk to you guys a little bit. Uh, hey, Pierce, Kaizo, we got, I think that's Bailey. Um, good, we got people in here today. That's good to see. So, what I wanted to talk about was how we're trying to figure out a way to move forward with making the Zoom rooms a little more functional. one of the things that we tried to do was I tried to post it on Twitter to see if, because that goes on our website and everything, to see if that would be helpful. And I put a password in, but I posted that in a second tweet on Twitter, hoping that it would be a little bit harder for anybody to discern and get in there that wasn't supposed to be in there. That didn't seem to work. There was one individual in there that, again, I need to figure out the settings properly. We were working on that. That took, that was showing off their screen and drawing random weird stuff and, saying weird things. We want to avoid that. That person thought it was supposed to be, once I started talking to them, thought it was supposed to be someone completely different, that they still thought they were supposed to be in a class, but the class did not seem to be ours. And not only that, I was surprised how they acted while in that room. Like, they should have acted a little bit better, but it happens. So we talked a little bit, and one of the things that we realized we need to set up is, I know not a lot of people use Twitter. It's just easy to embed Twitter into a website, so that's where we started, was with a little Twitter feed. We have gone even farther than that, and I'm going to show you this here. We have both an Instagram and a Facebook now. Some of you might recognize yourselves in some of these pictures. These pictures, the ones that we have, are from our Central Club right now. So on Facebook, we're just, at Future of Code, same as everything else we've been able to get. This is one of the ways that we're going to start posting information. As you can see, we have right here, head to futurecode.org for the YouTube link. Don't forget to log in your YouTube account, participate, chat. Tonight, at 6:30, we're posting stuff to this now. And then we also have our Instagram here. It's the same thing. It's at Future of Code. And we're posting this about the same stuff that we put on Facebook will be posted here. It might be a little bit different. I'm not much into Facebook. I'm not very good at using it. I won't lie. I haven't used it in a lot of years. But I do use Instagram myself personally, so if I find stuff that might be fun to post, I'm probably going to post it to Instagram. I'm probably not going to use Facebook a lot. I think that a couple of my other volunteers that are helping with social media stuff will use Facebook some and Instagram some. They might be a little more balanced than me. I won't lie to you. It's one of the drawbacks that I myself have, just my lack of knowledge with certain social media. What we're thinking is that if you would like to join in on the, and you guys can tell us whether this works or not. And hey, I just realized, sorry, my chat is acting really weird today. So if I don't see you, I'm sorry. I see Oleg is actually here. So Oleg is one of our, if you go to the, not the Central Club, but the Salmon Creek Club, you'll know him as one of the teachers. And he is in the chat tonight and is here to help you guys. So if you have any questions, Oleg is going to help you out. He's also going to tell me when to maybe slow down or stop talking for a minute. He's here to help us today, so that's great. Back to this. It's actually, Oleg was one of the people involved in this conversation. What we think we're going to do is ask your parents, or you can do it yourself if you have one of these accounts, but go in and before Tuesday, we will have a Zoom room set up, and it's going to have a password on it. If you go into Facebook, you go into Instagram, you go into go to Twitter. If you direct message us, so if you click on send a message right here, and I forget. Oh, I think I have to be actually logged in to find that button here. Send us directly a message saying, I want to be part of the Zoom room on Tuesday. We will send you the password for that day. We're trying to not post the password anywhere public. So I know this is how some of the colleges are doing it, is they're doing some direct chatting and trying to feed passwords to each other through these direct messages. That way we're not getting people who, I don't want to say don't belong because that sounds mean, but people that are there to cause problems are less likely to show up. So I think that's the way we're going to try it. Let's see if it works. This is just like learning all of this is just like coding. We're going to fail, we're going to mess up, but that's okay. We need to just pick ourselves back up. We need to try again, and we need to try something a little bit different and see if that thing that's a little bit different works any better or any worse. So this is the thing that we're going to try. Let's hope it works better. If it doesn't, then we'll keep working on it. Anything that you guys have to say, please, tell your parents to contact me. You can contact me. I do want to mention that if you don't have social media and you still want to get into the Zoom room, if you go to futurecode.org, scroll all the way to the bottom, there's an email right here for questions. Contact admin@futurecode.org. That comes directly to me. I'm more than happy to take anything that we're doing. If you want to change it, if it's not quite working, if you can't get a hold of us well, this is a direct link to me. Go ahead and email me. I'm more than happy to answer questions, and we can get this all figured out. I'm here for you guys. If it doesn't work for you guys, then we need to figure out how to do it better. So let's keep doing that. That said, anything that we do, we're still trying to record it. That is a key goal right now, is that if we've taught it, we should be recording it if we're doing this social distancing thing. So it will all still be showing up on YouTube. I don't want you guys to feel like because you missed a class that you can't come in and continue where we left off with the project. I want you guys to still be able to go back and work through that project. This is why you subscribe on YouTube, hit notifications. This is why you can leave comments in the comments section. Bailey can attest that I respond to comments. Just let us know what we're doing wrong, and we will make sure it gets fixed. We're more than happy to work this out. This is a learning experience for us all. So anyway, I'm going to get off my soapbox there. Let's get to coding. So, if you weren't here with us last week, that's okay. We have a copy for you to work with right now. So what we're going to do is we're going to go into the search bar, and we're going to search for Future of Code. Just like this here. Future of Code. No spaces, just one word. And let's hit return there. Now, we have two of these here. Make sure you pick the right one. We have Match Game Template. This is if you want to go back and you work with last week's video, you use Match Game Template. I'll probably change the name of that to Part 1 so it makes more sense. Tonight, we are going to use Match Game Part 2. So go ahead and click on Match Game Part 2. If you were here with us last week, just open up Match Game and hop on in. We're going to start from the same spot so we all know what's going on. Okay. So this is where we left off last week. And Bailey, I'm sorry. You always are like, "What are we doing, Chris?" You like stop talking and start teaching. I get it. Sorry. I promise as we get this figured out, I'll stop talking less before the videos and we'll just get right into teaching. Until we get it figured out, I have to communicate some more. Sorry to talk so much. I don't like doing it either. I like teaching better than talking about social media. Okay. So hopefully you guys have this open. We started with a couple things. We started using functions more the last couple weeks. Functions are great. They split things into individual sections. And this is what we started to do, is think about what are these individual sections that we need and how do they function and how can we split them out to make only one part of our code work a specific way. And sorry, I got hair in my face there. And this is what we came up with, is we're going to start with our main function here, which is when green flag is clicked. This is where the whole program starts off. Now what we do here is we're going to go in, and first thing we're going to do is initialize everything on our game that needs initialized. This means resetting the score to 0 maybe, or moving characters to the right places. In this case, we're going in and we're taking the card and we're moving it to the bottom left-hand corner. We're setting our card numbers back to 0. We're switching our costume to show the back. And then we're resetting our cards picked so that we don't have any cards picked at that moment. We want that blank because this is where we're going to store which card we have picked to place inside of our deck. That's on the table, that is. Next, we're going to go through. We're going to create all the different. I'll show you what this looks like. We're going to create the 4x4 grid. This is going through and just using this nice place cards equation here. And by knowing which card number is assigned to each card, which starts 1 here, 2, 3, 4, 5, 6, and so on, down to 16, we can actually place it in an X and Y location. The next thing we're going to do is then we're going to, once all the cards are placed, we're going to pick the cards. So what we did here was, if you remember, our costumes are labeled 1 through 8 for our 6 through King. Now, what we do is we decide to add a little bit more randomness to this. We decide what card we're going to pick in a random order. So we don't just say, okay, place 1, place 2, place 3. We add more randomness to it. Now, this may seem redundant. In real games, it's not redundant because random in computers is not actually random. So the more time you do random things on top of each other, the more random the game will actually be. It's really hard to explain, but computers they don't choose randoms. They don't choose numbers randomly. It's very obnoxious. So once we have our cards picked, we'll come through here and say, okay, let's pick card number 4, which if we go to card number 4, that would be our 9. And we say, okay, place card number 4. And this is where we have all of these spaces here, but we need to hide that specific card underneath 2 spaces at any given time because they're pairs. So we have to pick a random space and then pick another random space and hide the cards under those 2 random spaces. So maybe if we picked 4, we're going to hide number 4 here first, and then the second its partner, will maybe hide, I don't know, right there. That's where we ended. This is where we're going to start today. So, as I just mentioned, we're going to place 2 cards. And this is where we get our hide card function, just to be clear. This is what we're going to start building out, so make sure that's in front of you. Now when we hide a card, like I said, we have 8 different cards that we're hiding, but there's 16 spaces. So again, we hide 2 cards each time we hide it. That means we're hiding a pair. So what we want to do is let's go into Control, and we're going to grab a repeat. And since we're hiding 2 cards, we're going to repeat this twice. So each time we run through this loop, we're going to hide something. Now you're going to notice that hiding the card is not going to be much different than picking the random of the cards. And the reason being is, like I said, this is kind of a stacked way of doing random that really messes with the user and makes sure that it is as random as it can be. They're going to look very similar, and the reason is good. It's because we want them to behave very similar, but the end goal is a little bit different. We want it to be random. We want it to pick a random card, then pick a random space. Like I said, just what it does with it is going to be slightly different. Okay, so what we're going to do is, first thing that we did here, we set a random pick from 1 to 8. So that was where we picked a random card here, right? We want to do the same thing with hide a card. We're going to try to pick a random location here. So what we need to do is we need to store that random location. You'll notice if we go to variables, we have hiding location is already one of our variables. Remember, I put a lot of these variables in here for us ahead of time. We're going to create some new ones today, but I put a lot of them in here ahead of time. So let's take set, and mine says set card number to 0. Let's drag that out, and we're going to change this to set hiding location. Now, we need to pick a random, like I said, But I want to see, and I'm going to give you guys a second here and let the stream catch up. What random do we need to pick? I'm going to go grab the random operator, but when I put the numbers in here, like this one says pick random from 1 to 8, down here for hiding location, what numbers am I going to put in there? 1 to what? Please let me know in the chat. Let me see what you think is going to be the proper numbers to put in there. So as I'm waiting for you guys here, I'm going to go to operators. I'm going to pick random, and right now it says 1 to 10. I want it to start at 1, but what is the second number? I'm going to give you guys a second, and while I'm giving you guys a second, I'm going to get a drink of water. I really wish I had some like Jeopardy theme music or something. It would be really appropriate for right now. Just like ba-da-da-da. Sorry, you guys don't want to hear me. All right. I just heard myself ask the question a second time, and I don't see anybody responding yet. I'm going to give just a few more seconds. I'm not going to call anybody out. It's going to be really hard to call anybody out on this just because of the time lag. But I want to see if anybody picks, and I'm going to give it, I don't know, 5 more seconds. All right. Nobody answered me. That's okay. You guys are apparently shy today. So when we picked the random card to place, remember we picked 1 through 8 because we had 8 different locations here that we could choose from in our costumes. When we're hiding the card, we're looking at the, see, I like Oleg's calling you guys out. It's not just me calling you guys out now. I like this. All right, we're hiding the locations here. This is where they're going. This is our hiding locations, is in one of those spots. So one of those spots is anywhere from 1, which is up in the top corner, and that is down to 16. So let's do 1 to 16 here. I'm even hoping that I am still talking because there's a lag. I'm hoping someone will say something. Like, jump out at any time and say, I know the answer. Okay, so let's pick random. We're going to put that in our hiding location. Set hiding location to pick random 1 to 16. And by the way, I know some of you, like if you're watching this later, I might not know you. But those of you that are in the chat right here, I know some of you are really, I know actually all of you that are in the chat right now that have made me aware of who you are. I know you can probably guess the answer to this. So don't be quiet. I know you guys know the answer. You're pretty good at this sort of stuff. So open your mouth, say something. Let's talk a little bit more. Okay. Now that we have this, we're going to drop that in the repeat twice. And this is because each time we're going to pick a random spot twice. So here's the problem, though. We're going to run into an issue with this type of algorithm. And the reason being is because it's random, it has the ability to pick the same number more than once. And that's what we do up here. We kind of check in this not, if we check to see what cards have been picked, and if the random number we just picked has already been picked. Well, we kind of need to know that here. And so we need to track that. We need to track if a card has been placed somewhere in here. So there's a way to do this, and that's through lists. We can actually create a list with 16 locations in it, and then we can say, okay, this location 1, which represents card 1, is the number in it 0, which would represent no card, or is the number in it 4, which would represent, I think, 9 is what I said, the number 9 card. We can actually track our locations and see if anything exists in those locations, and then we can place cards in there. Not only that, but it'll work as our computer's memory. Then our computer will know what card we hid where. So we need to make this list. We haven't made it yet. This is a problem. So let's go in and we're going to come back to this repeat. When green flag is clicked, repeat 16 times. We need to come back here and say, okay, well, we need a list that has 16 locations in it. So let's go down to variables, and look at that. I have cards placed as a list. This is going to tell us which cards have been placed in what locations. So we need to create a list that is at least 16 long. It could be longer than that, but we need at least 16. So what we're going to do is we're going to take the add thing to card placed, and we're going to grab that and we're going to drop that in the repeat 16. So when green flag is clicked, repeat 16, we're going to drag that and we're going to drop that right below change card number by 1. And then we're going to say, where it says add thing, we're going to say add 0. Now look at what this is going to do. Ignore that right now, but look at that. We got a problem, don't we? I said add 16, and it added 16, but it added them to the end. There was already some data stored in there. Well, look at that. We got a bug. So we did add 16 more locations, but we already had 16 in there. That's my guess, judging by that we had 32 as our length now of our list. So let's go back to initialize. Now we know we need this, but we want to make sure that anything that was saved from a previous game is now deleted. So let's grab delete all of cards placed and let's drop that into our initialize function. All right, now let's see if this fixes our bug. This is the tough part about adding something once we decide we need it later, right? We said, oh, well, oh no, we need something to track this, but we need to make sure that we're making it and creating it properly. But now we got to go back to code we already wrote and edit that code a little bit. This happens a lot. So let's click when green flag is clicked. Let's click the green flag. And look at that. I get a length of 16 and they're all zeros. All right, that's what we want. This list of 16 is representative of our 16 cards. That way we can identify, we can hide a card, and then we can keep track of where that card is hidden. Okay. Giving you guys a second there if you need it. Now, we have this set up. This is great. We have a list. We know that the list is, there's no card placed. What we're going to do is we're going to put our number, our costume number, 1, 2, 3, 4, 5, 6, our hiding location, our costume number. Sorry, I had to rethink that for a second. We're going to hide that in there. And like I said last time, this is why we created the my card variable right here. So when we made this function, we made it to where it has a variable inside of it. And what we're doing is we're telling it, the function, when we call the function, we're saying the random number we picked from 1 to 8, which represents our costumes here, we're just going to pass that number from this function over to this function so it can keep using it. The problem we have at this point is, like I said, when we pick a random, if I pick a random and it comes up with 1 and I hide a card there, if it comes back around because it's a repeat and picks a random again and it also picks 1 again, I am going to have a 1 there, or I'm going to have a card hidden there. I don't want to place something in location 1 if there's something already placed there. So what we're going to do is when we place a card, we're going to store which costume number it is using this my card variable. And then we know we can check, and the next time we come to hide something here, we can say, is something hidden here? So that's what we're going to do now, is we need to check to see if there's a card already hidden in the place where we picked a random number. And this is where we're going to use repeat until. So let's take a repeat until block and we're going to drop it right inside our repeat 2, but below our set hiding location to pick random between 1 and 16. And now we're going to check in this repeat until. What we're going to do is we're going to make it repeat until we know that the location we found has a 0 in it. So we're going to need a couple things for this. First, we need to check it. We need to know the hiding location, because that's what we're checking, right? We need the hiding location. We picked a random one. Now we need to check that hiding location to make sure it is empty. So let's go to variables and let's grab hiding location. The hiding location, we know the number of the hiding location, but we need to check this list and check if that hiding location has a 0. So let's go into lists, scroll down a little bit in variables there, and we are going to look for item 1 of cards placed. It's a pill. So this hiding location is the number of the list. So we're going to drop hiding location over that 1. So it'll say item hiding location of card placed. And what we're going to do inside this repeat until is we're going to keep drawing a random until we find a location that is 0. So we need to go to operators and we're going to say equals 0. We're going to grab the equals 0. Drag this pill that says item hiding location of cards placed into the first section. And in the second section, we're going to put a 0. Okay. Now that you have that, we're going to drop that in the repeat until. And like I said, what we're going to do is we're going to keep checking if what this is doing is it's saying we're going to pick a hiding location. Then we're going to check that hiding location. If the hiding location is 0, if there's nothing hidden there, we're not going to do what's inside of here. If it is not equal to 0, meaning that we've already hidden a card there, we need to find a different random number. So we're going to actually just repeat what we have here. Set hiding location, pick random to 1 to 16. So I'm going to go to variables, and I'm going to say set card number to 0. We're going to change that to hiding location. And then I'm going to go to operators, and I'm going to pick random from 1 to 16. You'll notice that's already what we did. We're just repeating it. And we're going to drag that into the repeat until. So this makes sure that we found some place where a card hasn't already been hidden. Which is really important because we don't want to hide every single card under one location. Like if it picked 1 16 times in a row, which is highly unlikely, but if it did, all of our cards would be stacked right under this hiding location. It wouldn't be very good. That would be a terrible game. Nobody would play it. So now, if we've gotten past this repeat until, that means that we've found a spot with a card that isn't hidden yet. We need to hide one. Remember, my card is this pill here. We're going to drag that out. Let's drop that down below here. I'm going to zoom in a little bit for you guys here. So we're going to take my card, and now we need to save it to the location that we found in our list. So let's go to variables, and we're going to find our next 2 items in variables here. This is a little bit tricky. The way lists work aren't exactly friendly. Sorry, just looking at chat. I don't know if that got solved or not. Stop talking now. That was a while ago though. I saw that a little bit ago. I gave you guys a couple pauses hoping that you caught up. I hope that helped. Excuse me. So lists, I'm just going to tell you guys what we need. It's called the replace item. So it says replace item 1 of cards placed with thing. This is kind of weird. I don't like replace. I prefer the word update, and I think that's the way to think about it. Is what we're going to do is we're going to take whatever item is in here. So let's say that my random location was location number 5. What it's going to do is it's going to remove the 0 and then add my card back into it. I don't really like the word replace because I always want to say add or insert. Those are words that we use a lot, but what insert actually does is it'll add a whole nother, both add and insert do this, it'll add a whole nother row in here. So it would actually grow to a length of 17. It would think that we had 17 cards in here. So each time we did that, it would cause some really weird issues. We want this replace. It's really hard to explain. It's a little obnoxious, but we get by. Let's just go with it. Just trust me on this. The last thing we need is we need the hiding location. We need to know which hiding location we picked. So what we're going to do is we're going to replace item in our hiding location of our cards placed list, and we're going to replace it with my card. And then once we have that built, we're going to drop it right below the repeat until. Now, if I show, you can show a list by clicking on the checkmark box right next to it. If I show my list and I press the green flag now, it should, look at that, it should populate my list. There we go. And I should only have 2 of each card in there if we did it right. If we didn't do it right, come talk to me Tuesday on Zoom and we can figure that out. So now we've hidden our cards. That's good. That was a big piece of the game, actually, is just hiding the cards, is making the table look good, showing where we should have things, letting the user be able to see what's going on with the game, but then hiding the cards is the other big piece of that. The second big piece is what we're going to do right now, is it is the actual game. What happens when somebody wants to play? We need to have some actions when that person wants to play. It gets a little bit tricky, but we'll go through it quickly, I think. And one sec, I'm just making sure that we have everything we need. Okay. Now, thankfully, when we have something built, when a user clicks on an item, and that's what we want, is we want to check to see when somebody clicks on any one of these cards. And then when they click on the card, we need to do a couple things. If it's the first card we picked, we need to just flip it over, and then we need to remember what that card number was, so that we can compare to the second card we flip. So if it's the second card I flip, we need to know that it's the second card we flipped. And when we flip the second card, we then need to compare it to the first card and see, do they match? If they match, we're going to remove them from the table. If they don't match, we're going to flip them back over so the user has to try to remember what was there. So the first thing we need to do is we need to just flip the card over. I'm going to move hide card over to the side here. And we're going to start. Let's go to events. And we're going to grab when this sprite is clicked. So when this sprite is clicked, the first thing we have to do, like I said, is flip it over. Now we do that by just changing the costume. Now, we know that if this, remember when we created all these clones, we gave them a number. And that number was called card number. That's what our variable was, card number. So we have a card number assigned to all of these. So we need to place that card, right? Or we need to figure out what's there and place the right card there. And that card is memorized in our list here. So we're going to use card number, and then we're going to look at that card number. So if I click on number 1 here, it has a card number 1. We're going to look in location 1 of our cards placed list, and then we're going to find what card number 8 is, and we're going to switch it to that costume. So what I just said, let's just start with the easy one. We're going to switch our costume. So let's say switch costume to, and I'm going to grab back. And we're going to drag this in and just drop it in the when this sprite is clicked. Now remember what I told you about this, that remember back has that pill shape. That means we can put items in there. We can drop it, even though it's a list, we can put items in there. So let's go, we know that we're going to grab the card number and the list, and we need to figure out what the number is inside the list here. Let's go to variables. And we're going to pick card number as our first variable. And the second question is, the second block is going to be item blank of card placed. And that is a pill shape. Item 1 of card placed is what it has right here. And we're going to drag card number into there. So when we click on this, we know which card number we are. Then we go into our list and we find what that number is, and then we're going to switch the costume. So let's go ahead and drag that in there. So remember, this is kind of like a function here. We're giving it an input and it's giving us an output. So we're saying take 1 and let's look inside here and tell me what is inside that list at that spot. So there we go. We know we have it working here. But we've only got a little bit done. Notice I can pick all of them and they don't flip back over. So just trust me on this, it makes it look better. This next piece, we're just gonna go to a control and grab wait 1 second and drop it right below switch costume. It's going to matter later on. Just trust me. It just makes it look nicer. It makes it respond a little bit better. If you pick the second card and keep doing the code we're going to do, it only flips the second card over for a very, very like half a second and then flips both cards back over. So you don't have time to memorize it. This gives you 1 second to memorize it if they flip the cards back over. It's kind of a user interface thing. It makes it look nicer. It doesn't mean much. Not to the way our program runs. It means much to the way it looks. Okay. Now what we're going to do is we're going to actually create a variable now. And the variable we're going to create is called quantity shown. And what we're doing here is we're trying to figure out, we're trying to let the computer know how many cards have we flipped over. Because like I said, we can keep flipping over cards. We only want to be able to flip over 2, and then we want different things to happen. So we need to track how many cards the user's flipped over. So let's go into make a variable. So go to variable and then make a variable. And you're going to call this quantity shown. And go ahead and press OK. You can do for all sprites or for this sprite only. It doesn't matter in this situation. Just click OK. Excuse me. This is going to help us track how many cards have been flipped over. So each time we flip over a card, we need to increase this number by 1. We're going to start at 0 and we need to increase it by 1. Well, there's something I just said, right? We need to start at 0. One of the things we need to do is let's go back to initialize. Let's go back to our init. See, this is why we use functions, because I keep saying, oh no, we added something else, but we got to make sure we reset that when the game starts. it's a lot easier to put it in initialize than to try to figure out where in your code, if you have this big long chain of code, where it should go. So let's go back to init, and we know that we need to make sure this is 0. We always start at 0. We don't have any cards flipped over, right? So let's go and we're going to say set card number to 0, but we're going to change card number to quantity shown. All right. Well, we got that reset. That's good. We gotta think about that each time we add something. We gotta make sure that at the beginning of the game it starts where we want it to be. And in this case, nothing's flipped over, so it should be 0. But now that we've clicked on something, we'll notice that this quantity shown is still 0. We want to flip that back over, and I'm going to get rid of cards placed there so we don't see that anymore. So let's go ahead and we're going to say change. We're going to drag in change card number by 1, and under when this sprite is clicked and the wait 1 second, we're going to drop that right below, but we're going to change it to quantity shown. So we're going to change quantity shown by 1. So this gives us an option to, now we know how many cards have flipped over, and we can do different things based on how many cards have been flipped over. So let's do that. We have, thankfully, because it's only 2 cards, we've created a binary for ourselves. We either have 1 card flipped over, or we have 2 cards flipped over. So with a binary like this, we can actually go in and use an if-else statement. If 1 card's flipped over, we do one thing. If it's not 1 card flipped over, if it's 2 cards, then we do something else. So let's go into events, or excuse me, let's go into control and grab an if then else statement. And I guess I use the word binary, and some of you may not know what that means. So binary is we have true or false in computer science. That's binary. It's 1 and 0. It means that something is true or something is false. In this case, we don't use 1 and 0. We can use 1 and 2. It's still a binary because there's only 2 choices. It's either 1 or 2. You could say we have a third with 0, but we're never checking it because we only check this after a sprite is clicked. So therefore we dismiss 0. 1 or 2 are the only options we have at this time, especially considering that I know you say, well, look at this, we can flip over way more than 2. Yes, but we're going to make it to where once we hit 2, we reset the number back to 0 every time. Again, therefore, we still have a binary. Only 2 choices. So let's check that. What we need to check, like I said, is how many cards do we have? The easiest way to do this is just check to see if you've hit your maximum. So let's go into operators, and we're going to grab an equal sign. And you can go ahead and drop the equal sign in the if-then symbol. And change 50 to 2. And remember, what we're checking is how many cards are shown. So we're going to go into variables, and we're going to take our quantity shown variable, and we're going to drop that into the first part. So it's going to say if quantity shown is equal to 2, then do something. Otherwise, do something else. So I'm going to do this a little bit backwards. I'm going to do the else first, because what this means is if we found 2, then we got to do something in this first part here. Well, if we have 2, we assume that we've already kept track of the first card. Well, we haven't kept track of the first card yet. We don't know what the first card is. If we picked it, we have not found a way to store it yet. We need to store that card. So we're going to check that. So let's go into else, and in else we need to, like I said, we need to find a way to store this. We need to know which card was picked. So let's go to variables, and we're going to make one more variable here, and I called it first pick. I want to know what was picked first. So let's figure out what our first pick was. We're going to try to remember that first card we picked. So when I click on this card here, we need to say, oh, it was a king. Let's save that card. And we're going to save that to the first pick. So let's go and grab set card number to 0. We're going to drag that into else. And we're going to change that to first pick. So set first pick to 0. Now we don't want it to be 0, right? We want it to be whatever card is actually hidden there. Because remember, 0 in our game means there's nothing there. It means it disappeared. It's gone. It means there's been no card there. So we don't want to save 0 there. We want to save king. Well, king is represented by a costume number, number 8. And if we go to looks and scroll down just a little bit, we actually have costume number here. So let's save our costume number to our first pick. It's kind of an easy way of remembering which card it was, just using the costume number. Now, I'm going to see if this works. We have first pick here. Let me restart the game. And first pick changed to 2 because I had a 7. Well, let's check that. Costume number 2 is in fact 7. That's good. It's saving it. Now we have a memory of what we picked. Now what we're going to do here is in this if we get 2 cards picked, so when we pick the next one, we need to compare this costume number to this costume number and see if they're the same. If they're not the same, then we have a problem. And we're going to do 2 different things. If they're the same, we're going to make the cards disappear. If they're not the same, we're going to flip them back over. Now, once again, I created a binary, right? I created a situation where I have 2 options. So in our if statement here, we can actually put another if then else inside of that because we created another binary. We have one situation that is true or false that leads to certain results, and one of those results also leads to a true or false. So let's go to control and grab an if then else and drop it inside the if section of our first if then else. So these are nested conditionals. This is kind of cool because you can start with a big option of items, and you can slowly whittle them down to do something specifically that you want. A good example of this might be if you guys have ever played 20 questions. 20 questions is actually nested if statements. So it's nested binary choices, and maybe I'll do a video on this one day. I don't think I could do it in Scratch, but I can do it in other languages, and it's actually kind of cool, and it's not too difficult if you do it right. But a 20 questions game is actually you can develop a 20 questions game by just saying if yes, then try this question. If no, then try this question. And this is how people who are really good at guessing things can kind of get information out of you, is by playing 20 questions. And, it starts with certain things like, is it human? And you say, yes, it's human. Well, then I just took a wide group of things, rocks, President Lincoln, Elon Musk, a pencil, and I just put all of those in a bucket together. But when I asked, is it human? And you said, yes, it's human. I just took out all the inanimate objects like rocks and pencils, and I don't have to worry about those anymore. Now all I have to worry about is humans. And now my next question can say, is he alive or dead? Or is she alive or dead? And you would ask, is she alive, right? You try to choose binary questions, because in 20 questions you can only answer yes or no. And you say, yes, alive. And you're like, well, I have Elon Musk and President Lincoln in here. Well, President Lincoln's dead, so I put him aside, and now I have Elon Musk. and whoever other, alive people you may have still in that category. So even though you started with a big box of things, by doing these if then else statements, you can whittle it down. And that's what we're doing here, is we're trying to whittle down what do we do? What situation do we do? I hope that makes sense. It's kind of a fun way to think about doing if then else statements. Feel free to ask questions. You can put questions in the comments too. If you guys do want the video of the 20 questions program, it's really fun. As you answer the questions, you can actually give it an answer, and your 20 questions game will actually become smarter. It's pretty cool. Okay, so let's come back to here. So we know that 2 cards have been picked, but now we need to compare them and say, well, do these costumes equal each other? Well, we know that we saved the first costume number into our variable first pick. So now we need to compare it to our second costume number. So let's go into operations, and let's grab the equal sign. And in the equal sign, we're going to put our 2 variables. So our first variable is first pick. Let's go ahead and drop that into the first spot. And like I said, that's comparing our old costume number, our first one, to our second costume number. Well, all we have to do is go to looks, and let's grab our current costume number. Because remember, when we click on this sprite, it goes into this specific, it goes into this code for that specific sprite. So the costume numbers are unique to whatever sprite we clicked on. So we can compare these. Now, if they do match each other, that means we have a match. That's great. And that's going to be in the if statement here. If they don't match each other, we're going to do something else, and that's flip them back over. Well, so far that's the easiest thing to do. So let's go ahead, and we're going to come in here and say else we're going to flip the cards back over. We're going to change them back to back. The easiest way to do this is let's go into events and let's put a broadcast in there. We've been using broadcasts a lot. They're kind of nice. And we're going to broadcast the message no match. And what this is doing, why we use a broadcast, is because we can tell this card to flip back over, but we want the card that we already flipped over to go back to the way it was. Well, we're not looking at that code anymore. That card is kind of sleepy now. It's not really paying attention to what we're doing. But with a broadcast, we can wake it back up and shake it awake and say, hey, do something. So now let's go and grab when I receive message 1 and change that to broadcast no match. So when I receive no match, we're just going to, this is going to be really simple. We're just going to tell everybody, we don't care who it is, because it's all going to turn out to be the same. We're going to tell them to switch costume to back. So let's try this. I'm going to try this now. So switch costume to back. All right, I picked a jack, and then I picked a queen. Look at that. It gave me 1 second. That's why I put that 1 second delay in there. Gave me 1 second to look at them, and then it flipped them back over. That's kind of the challenge of this game. See how quickly you can memorize it, right? But look at that. We got it back to looking normal. Oh, man, I got a weird bug there. I'm not sure why. Oh, I do know why. Haha. We haven't completed our code yet. Sorry, I was doing this without looking at what's going on. So there's something interesting here. Let's look at cards picked. Oops, excuse me. Not cards picked. Let's look at quantity shown. Let's watch quantity shown here. I pick 1. Quantity shown becomes 1. I pick a second one. Quantity shown becomes 2. Our cards flip back over and our quantity shown still says 2. Well, that's not right. Because if you look at our board, there's no cards being shown. So let's fix that. Now, I'm going to tell you guys where to put it, and I'm going to tell you it's just easier to do it this way because no matter what, we always want the quantity shown to reset. No matter if the cards match or if the cards don't match. So what we're going to do is we're going to come in here, we're going to grab set card number to 0. Let's drag this out so we can change it a little bit. And we're going to say set quantity shown to 0. And what you're going to do is the second if-else statement right below the broadcast but outside the else is where we're going to drop it. So see, it's not. So we have our first if statement. We have our second if statement. It's going to go right below that. You could put it right below broadcast, but you'd also have to put it right below in the if statement too. No matter what, if we do one or the other, we still always have to set it back to 0. So I put it down below just so that I'm not duplicating code. Now let's try this. Let's reset this. And let's watch quantity shown here. Quantity shown 1. Quantity shown 2. Well, you didn't see it. It was pretty quick that it runs that. But it changed to 2 and then changed back to 0 when it flipped everything back over. Now, if we pick those again, it should keep doing the same behavior. We've gotten rid of that bug now. Alright, just looking at my notes, giving you guys a second to catch up if you need it. You guys are doing good. Alright, so the next part is getting rid of these if they match. So if I pick a 10 and I happen to pick another 10, I want those cards to go away. I don't want them to stay on the board. So we're going to do another broadcast because we want both the cards to disappear, right? Well, let's go into events and let's grab a broadcast and drop it in the if section of first pick equal to costume number. And we're going to create a new message and we're going to call it excuse me, sorry. We're going to call it matched. Now let's come down here and we're going to say when I receive matched, we need to do something. Well, remember these are all clones. And what we can do to get rid of a card is we can remove it. It's a clone, we can just get rid of it. Or we can hide it. Either way works. I say right now, let's try to hide it. So if we received when matched, let's hide this. Now let's look at this. I'm going to grab hide and I'm going to drag it below when I receive matched. I'm going to restart my game and let's see if I can find a match. So we got a 9, a 9, an 8, king, 6, 8, 8, and uh-oh. Look at that. Because broadcast doesn't just send to the clone I'm working with, or the 2 clones I'm working with, it sends to everything. Well, we have a problem now. There's another bug. So let's, we got to show it. So there's another bug, right, when we restart it. So let's go back to init. And in initialize, we want to make sure we show all of our cards. Okay. Okay. That's okay. We can figure this out. So we show all of our cards again in init. Let's go back down to hide. Now let's think about this. I am doing an action here that's showing cards. Well, I only want to hide the cards that are matched, which, okay, we've done that. We've determined that they're matched. But I don't want to hide the cards that are showing their backs. Well, there we go. We'll use that. We don't want to show the cards that are hiding their back, or that are showing their backs, excuse me. So let's check for that. We're going to check to see, is this card showing its back? And if it is showing its back, then we won't hide it. So let's go to control and let's grab an if statement and we're going to drag this in and just put it off to the side right now. Now, what number is the back? This is what we need to figure out. How do we identify the back? And then we identify the back as being costume number 9. Okay, We can work with this. So let's go and grab in looks. Let's go grab costume number. Now we want to check and see when it's costume number 9. So let's go in here and grab an operations, go to equals, and grab an equal sign, and let's drag costume number into the first spot, and then make the second spot 9. Okay, so we have checking to when it's 9. Well, that checks when it's here. Let's do it. So I'm going to put that in the if statement, and I'm going to put the hide inside of there. So if costume is equal to 9, then hide. All right. Now let's see what this does. I want to see what this does, because I have a feeling this is going to be another bug that we need to fix. So let's check this. It's 10, 7. There we go. 7 and 7. Uh-oh. This hides everything else but those two. That's not what we want either. But we can fix this. And we can fix this because we're checking to see when the costume is equal to 9, then we hide it. Well, we want to know when the costume is not equal to 9, which 7 and 7 are not equal to 9 because those costume numbers are costume number 2. So let's go into operators and let's grab not. Now let's take this costume equal to number 9 and drop that in not. So now we want to know if the costume is not equal to number 9 or the back, then we're going to hide those costumes. Let's try this. Okay. I knew better than that. There we go. 8 and 8. Hey, look at that. Now we got it. This is great. So let's keep playing this game. Let's see if I have any more bugs. I forgot what the numbers were. I wasn't paying a lot of attention. You guys should be here helping me with this. This is why you guys are usually in class, is to help me figure this stuff out, right? Okay, let's keep going. Do we have any... Oopsie, you can kind of cheat a little bit there, can't you? If you click really quick, you can see all the cards, but we won't solve that today. And there we go. We got all of them. So we know this game works. I'm going to stop this here tonight. It works well. Let's go back to what we were talking about earlier. Tuesday, I am going to do a Zoom Q&A to where you guys can join me. Go to our Facebook, go to our Instagram, go to our Twitter, or just email me directly. Some of your parents actually have my cell phone number too. I'm okay with text messaging if you want to text me. Let me know that you want to join. I will go ahead and I will give you guys the information, and you guys can get the passwords. You can get in. We can try this again. Oleg has been helping me out with it. He just sent me some more information today on how to make it better. We're gonna get this working. We're gonna rock this. We're gonna figure this out. If you guys have questions about your code, we can work on code that you've seen here on YouTube. We can work on your own code. We will get everybody kind of hanging out and helping each other out, and we'll have a lot of fun. I think it'll be fun. We just need to figure out the intricacies of it. So we're gonna do it. I know we can. We got good people working on this. Anyway, I'm gonna say with this project right here, I'm gonna put it out to you guys. I'm gonna do a little bit of challenge. If you guys have questions about it, you can ask me in the comments and I will definitely answer. I would like people other than just us to see what you guys are thinking. My challenge on this is, can you add a scoring system? Now I'm going to tell you, when Trevor designed this, his scoring system was kind of cool. When you started the game, it started a timer, and that timer continued to run until you clicked all of the matches, and then it stopped and it told you what your time was. I thought that was a pretty cool scoring method. you can do other stuff too. Maybe you give the person 1 minute and see how many times they can solve all 16. You know, try something new, try something different. Try to put a scoring method into this game. If you guys have questions about that, let's talk about it on Tuesday. If you guys are watching this way in the future and you're not on the stream right now, but you're watching a replay of it, same goes for you. Come and see us, figure out when we're doing our next Zoom meeting, contact us on social media. We will get to working with you guys and we'll see how can we figure this out and keep doing this with into the future. We want to keep doing this. We think it's cool. It's fun. So that's my challenge for you guys. I'd like to see that. I think it would be really cool. And you guys are all creative. You always come up with a different way to do something when I put a challenge out to you guys. So go ahead, give that a shot. I would really appreciate that. Other than that, I'm going to call it for tonight. You guys have been really quiet tonight. I'm super surprised. Don't be afraid to be quiet next time. Oleg's here to answer your questions or to just chat with you guys. He's a nice guy. He's really pleasant to be around. I talked to him for like 45 minutes on the phone yesterday. He's really, really pleasant. So don't be afraid to chat and be, social. So with that all said, I want to say stay home, stay safe, keep away from each other, wash your hands, sanitize, all that good stuff, and have a good night, coders. I will talk to you soon.